Hello class, this is Mrs. Albritton of Albritton's math class, AMC. So we're going to take a look at the Unit 4 study guide so we can prepare for our test that's coming up in a couple of days. Let's take a look at number 1, and keep in mind that your study guide is in GoFormative, so it's online, and it is open until the actual day of the test. So you'll be able to go back in and look at the problems, make corrections, make changes if you need to. So for the first one, we are going to take a look at this graph, and we're asked to determine what's the domain of the graph. If you take a look at the answer choices, you notice how they are given using the negative infinity and positive infinity. So when we do our domain, remember domain are the x values. So we're taking a look at the actual x values here. So these are the x values on the horizontal axis, the x-axis, positive values that way and negative values this way. So if we take a look at the choices, notice that the first choice, it gives us 2 actual answers. And this symbol in the middle means union. So here this says from negative infinity to 0.5. So that means we're starting from the left and we're going this way. And it says that it actually stops at 0.5, the way it's written. Well, if I start at the negative infinity and I start coming this way, that is -3, because here's -1, -2, -3. So this, remember that asymptote is like a boundary line. We can't go past that one. So it is actually stopping me at -3. And then again, when I cross over here, it sort of picks back up at +3 and then goes further. So I'm looking at the graph. It's coming from negative infinity and then it sort of hits that fence, that asymptote at -3, which means that this does not fit. 0.5, I don't see that. From negative infinity to positive infinity, well, we can't use that because the graph is sort of broken into pieces. That means it's not a continuous domain. The third one, negative infinity to -3, so as the graph comes from this side and then hits that boundary line and has to take off going upwards, it hits it at -3, so that seems to fit. And then it says the union, or combined with 3 to positive infinity. So here's 3, where it does start at 3, and then it goes on and on forever for positive infinity. So in that case, and of course this piece of the graph is enclosed between -3 and +3. So that means this would be good, except it's only telling us about this part and that part. But if you take a look at here, we've got 3 of them. So we've got this part, we've got that middle piece, which this part of the graph is enclosed between 3 and -3. So there's that one, and then here's starting at 3, this boundary line of 3, this asymptote, and then going on forever. So it looks like the answer would be the last one. That gives us the domain of all 3 parts of the graph. Number 2. So for that same graph, now we're asked to identify the end behavior. Remember, end behavior tells us what is the graph doing at the end as it proceeds. So when I look at this, we look at the first choice. It says as x approaches positive infinity, that means as the x values go to the right and get bigger, f of x, which is also the y value, remember that's function notation for the y value, approaches 1. So as the x value comes this way, it's saying that the y value only goes as high as 1. And it does, because that's our horizontal asymptote. So that one actually fits, but then we still have some other things going on. So we'll go ahead and check this one off. The next one, as x approaches positive infinity, f of x, or the y approaches negative infinity. And this says as the x values get this way, the y values keep going up higher and higher. And they actually don't in this case, because we've got this horizontal asymptote that's sort of blocking us off. So we can't use that. As x approaches negative infinity, y approaches positive infinity. So it's saying as the x values go this way, that the y values are getting bigger, and that's not true, because again, we have this horizontal asymptote that's blocking it. And the last one, as x approaches negative infinity, so as it comes this way to the left, the y is going up to 1, and it actually is. because of this horizontal asymptote. So we got two answers actually on here that fit. All right, let's take a look at number 3. So we're taking a look at this graph and we're asked to identify the horizontal asymptote of the function. Since we do have a picture of the graph, we've got a visual, we don't have to do the calculations to find it. We just simply need to look at the graph and the horizontal, which is going this way, level, instead of up and down, it's going from left to right, is this particular dashed line right here. And if you look at it, it is at y equals 1. So there is your answer for the horizontal asymptote. Now the next part of this, we're asked to identify the vertical asymptote. So for the vertical asymptote, we're looking up and down. And the dotted line or the dashed line that I see going vertically is at x equals 1, 2, 3, 4. So it's at x is equal to 4, which is that one. All right. Number 5. So take a look at this graph. This time we have a radical function. If you recall, this unit is on radical and rational functions. This one is a radical function. And notice that radical functions, one thing about those, they actually have a starting point. This one starts somewhere, so it's not coming in from negative infinity or anything like that. It actually starts at, for this particular graph, it starts at over -2 up +4. So at -2, 4. That's my x, this is my y value. All right, so the domain, the x values. As we can clearly see, the domain starts at -2, and from there this graph just goes on and on to positive infinity. That means we are looking at this choice here. This one says it starts from as far left as you can go. That's not true. That's not true. This does not start at 4 for the domain. It starts at 4 for the range. So let's do number 6. Now they want the range. So we just said that it starts at 4 for the range. This is the only one that begins at 4 for our range. And then from there it goes up and to the right. That means it's going to positive infinity, even with the y coordinates. So here we have our range.